Welcome guys to equations of motion. I have divided this topic into three parts. However, the ultimate aim is to understand Newton's equation of motion and how we can derive them using line graphs. In this part, that is part 1, we will understand various terms that are used to describe the straight line motion. In part 2, we will understand distance time graphs, velocity time graphs, and what all information we can fetch through those graphs. And in part 3, we will understand the three equations of motion and derive them using line graphs. So, let's get started with part 1, that is understanding different terms. So let's start with motion. When do we say a body has or an object has performed a motion? When there is change in position of the object with time. So for example, if initially the object was at this position, after say time 2 hours the object is found at some another position. Now the position of the object has changed. That means this object has performed a motion. So motion means what? Position of the object changes with time. Next is distance. Distance is represented by small s. That is actual path taken by the object. Say for example, this is your home and this is your school. You have to go to your school, but you suddenly remember that you have to buy a pencil box. So you need to go to the stationery shop and then you will go to school. So this becomes your actual path taken to reach the school. So this is your distance. Now there is another term called displacement, which is also represented by small s. Displacement is the shortest distance measured between initial and the final position of the object. So your initial position is the home and final position is the school. So shortest distance is the displacement. This shortest distance becomes your displacement. So there is a very fine difference between distance and displacement. Distance is the actual path traveled by the object, whereas displacement is the smallest distance between the initial and the final position of the object. Now the units of distance and displacement, that is the SI unit, are same, that is meters. We come to another term, that is velocity. That is speed. Speed is the rate of change of distance or the distance traveled by an object in unit time. So total distance travel upon the total time required. So in this case, this is the total distance travel, and how much time you require to travel this distance becomes your speed. So that is represented by small v. We have another term, that is velocity. Velocity is the speed of an object in definite direction. So when we are talking about speed along with the direction, then that becomes velocity. Velocity also is represented by small v. So here velocity is the rate of change of displacement. So this time required to travel this displacement is velocity. Now velocity and speed, the units are same. The SI units for velocity and speed are same, that is meters per second. However, one should also note that if the motion is along the straight line, then there is no difference between speed and velocity, or we say speed and velocity are same provided the distance is along the straight line. Like in our case, if you would have traveled from home to school directly, then in that case your speed as well as your velocity would have been same, because the distance and the displacement is same in this case. Hence, you should always remember, if the motion is along the straight line, the velocity and the speed are same. Otherwise, they would be different. Like in our earlier case, the distance and displacement were different. Hence, the speed and velocity are different. Also, you should remember, to specify the speed of an object, we require only its magnitude. Whereas when we want to specify the velocity, we need direction also. So when we specify direction of motion along with the speed, then it is called as velocity. So hope that there is a difference between speed and velocity and it is understood thoroughly. Now next we have is uniform speed or uniform motion. That means object travels equal distances in equal intervals of time. Say for example this. This is time and this is distance covered. So here you can see for every half hour, the distance covered is 20 kilometers. For each half hour, the distance covered is 20 kilometers. So object is traveling from here to here, say from point A to point B, but it is traveling same distance in same interval of time. Like half hour it will travel this much, next half hour again same amount of distance it covers, next half hour again same amount of distance is covered. So this is called as uniform motion or uniform speed, where equal distances are traveled in equal intervals of time. Now example of this, here we say velocity is constant with time. The velocity remains constant with time, or we say the change in velocity is zero. Now example of this is the highway vehicles. They have to continuously keep on moving and the speed is almost 80 kilometers per hour because we do not want any traffic on the highway. Hence the speed of vehicle is almost uniform. They are in uniform motion or uniform speed, having a speed of 80 kilometers per hour. Next is non-uniform speed or non-uniform motion, which means unequal distances in equal intervals of time. Now, the best example is the traffic, where the vehicles move at travel very small distances in equal intervals of time. So here in this chart you can see half hour the distance travel is 14 kilometers. Now next half hour the distance travel is 13 kilometers. For the next half hour, the distance travel is 14 kilometers. For the next half hour, the distance travel is 15 kilometers. So every half hour, the distance traveled is not constant. Hence, we call such type of motion as non-uniform motion. Here we say velocity varies with time and the change in velocity is not zero. The change in velocity, you can see it is not zero. Whereas here the change in velocity is zero because the velocity remains constant with time. Right? So this is the difference between uniform speed and non-uniform speed. Uniform speed means body or the object travels equal distances in equal intervals of time. Here object travels unequal distances in equal intervals of time. Next is acceleration. Very important term, acceleration. Acceleration is the rate of change of velocity. That is final velocity minus initial velocity upon time. So if the velocity of an object changes during certain time period, then it is accelerated motion and its SI unit is meters per second square. Now this is a unit for acceleration. So here you have to be careful with the definition. Velocity of the object changes. Now this change can either be that means the final velocity can either be greater than the initial velocity or the final velocity can be less than the initial velocity. And accordingly we have positive acceleration and negative acceleration. So when the velocity of the object increases with the time, implies acceleration is positive. That is, acceleration is in the direction of velocity. However, if the velocity of the object decreases with time, implies the acceleration is negative, or we say acceleration is opposite to the direction of velocity. Such kind of acceleration, that is negative acceleration, is also called as deceleration or retardation. Now next is uniform acceleration. Uniform acceleration means velocity either increases or decreases, but then that increase or decrease is by equal amounts in equal intervals of time. And non-uniform acceleration means velocity increases or decreases, but by unequal amounts in equal intervals of time. So these are all the terms that are very useful for equations of motion. So that's all in this video. Do like, share and subscribe the channel for more such videos. In part 2, I will be talking about distance time graph and velocity time graph, that is the line graphs, and what all information we can fetch through these graphs. So once again, do hit the bell icon besides the subscribe button. Thank you.